Hope everybody's having a good evening back for the Friday edition of our webcast. We've had that system blow through, as you saw on those time-lapse loops. We got maybe about 1/10 of an inch here, and it just blew on by and got some 20-knot gusts, and now it's kind of clear outside. And let me get the monitor going here. There we go. And now we've got the weather system out in the Midwest. And the center of the circulation is up here in Illinois. And I'll put the state outlines. And yeah, you can see that this was midday, though. You're looking at about 1 o'clock this afternoon, coming through East Texas and Illinois. And now it is a lot further. And we can look at the AWIPS. I've got that loaded up, and there it goes, pushing into Mississippi already. So already that's traveled about 200 miles in the space of about 6 hours. And you can see that these convective elements have a very forced appearance. You don't see discrete cells along it like you would see with supercells, or maybe kind of like a broken squall line or anything like that. This is more like kind of a leading edge thing here. You can see kind of an outflow line, and behind it just kind of a very stratiform looking area of showers. You can take a closer look at that there at around the Jackson area, and it looks pretty homogeneous all the way down, and only down in Louisiana do we actually start picking up convective elements. But even there, they don't really look all that impressive. And we follow that all the way down to Brownsville. Yeah, see, this is looking a little bit better down here. Those cells right there. If I was looking for severe weather, I would probably be keeping an eye on those right there. But, man, just going up the line just looks pretty weak. But it's not to say we don't have a potent storm up there. Look at that up there in Minnesota. This has the elements of, or the textures of snow. And this is the northerly flow coming in the backside of that storm. And I can guarantee you things are pretty bad shape there in the UP of Michigan and Lake Superior. I would not want to be out on a boat tomorrow morning on that lake. Let's look at the surface map very quick. And I've got Russia up here for some reason, but we can take a quick look at Russia. Why not? Looking at 32 below zero right here. They've got a river valley that kind of goes like that. I can't remember if that's the Lena, but it's a very wide plain. And they got some of the coldest temperatures in the northern hemisphere in that plain. And there's also some mountain valleys out here. And some of that cold air gets trapped in those mountain valleys, and there's one station here called Oymyakon that recorded something like minus 87 Fahrenheit. I think that was back in 83. So they really get into the ice box there. Not so much in Alaska. The cold pole of North America is in this area here. They've got kind of a small floodplain, and maybe I'll show you some pictures of that sometime, but there's a station here called Snag, Yukon, about right there. They recorded also around minus 80 way back in the 1940s. But nothing like that going on right now. If we pull up the plots, things are, we do have this one minus 11 reading here, but things look pretty seasonable for this time of year. In the Midwest, there's that storm going on in the Great Lakes area. And if we look at the wind flow, you can kind of follow that down. We find the low pressure system right here around maybe the Marquette area. I'm trying to remember where exactly Marquette is. I think it might be here. But in any case, looks like a 980 millibar, or 993 millibar low right there. And as this strong northerly flow on the backside comes sweeping in, and this moves off to the east, that's where we're going to have a situation like what sank the Edmund Fitzgerald. That was just behind one of these low pressure areas as it moved off the lake, and very intense northerly winds blowing across the lake really got some wave action going on through there. So following the front on down, you can see the leading edge all the way down to Missouri, or through Mississippi, pretty much like what you saw on the radar imagery. That's being driven by a very strong high out over the northern plains. We can see it here, centered around, looks like maybe around Scottsbluff, pretty much right in here. That's the center of that high pressure area. That's covering this area, and that represents the center of that polar air mass, which is sinking south and blowing cold air into the Midwest region. Okay, let me see if I had any charts set up to show you. Yeah, I wanted to kind of explain why these cells look so weak. On any normal day, you would think that you would get very strong thunderstorms with watch boxes and that kind of thing. We didn't get it this time. And the reason for that is, I can switch over to the soundings. This is the University of Wyoming sounding page right here. And I'm going to click on Shreveport. This is the Shreveport sounding for this morning. And what do we notice about this sounding here? Well, just eyeballing it without actually placing any parcels on it, we can see that there's this extension right here that kind of sticks out to the right. And we can see that this upper part here is not quite as far to the left as we would like to see. When I'm bringing up the sounding immediately, I expect to, on a severe weather day, to see that temperature line kind of extending up like that. In other words, I want to see this part of the sounding right here. I want to see that as close to dry adiabatic as possible. And by dry adiabatic, I mean it needs to follow these green lines that you see right here. The closer it is to that, the steeper the lapse rates and the better the potential for instability, high capes and that kind of thing. So we don't quite have that. If I lift a parcel up, we did get a little bit of moisture recovery here. We can see dew points here in the right around 60 degrees, maybe upper 50s. Pretty deep layer here, all the way up to 850 millibars. That's going to be about 5,000 feet thick. So if I lift a parcel and use maybe 75 degrees, I'm going to get something like that. And even with that, we've got a tremendous amount of capping. So that's kind of the story all up and down the southern U.S. There's this very strong cap centered at about 700 to 850 millibars right in there. And the other compounding factor is the marginal lapse rates. So the net result of that is you're not going to get much cape today. Maybe I can find a plot on the SPC experimental products page. Just put that in your search engine and that'll take you to the Storm Prediction Center forecast tools. And they've got these mesoanalysis graphics, and I should warn you that these are not really analyzed. These are kind of like, these are basically mesoscale model fields that are output. So you're basically looking at the initial panels of mesoscale models. So there's still some value in doing your own analysis. Okay, let me pull up the cape here. That's going to be under the thermodynamics menu. I'm going to pick the mix layer. And it's not showing any instability except just offshore. We got one little 500 right here off the Texas coast. And then we start getting into 1,000 values where I was showing you that cell off Brownsville. Let's see how it's doing. Come here, cell. Let's check you out. Yeah, it's looking pretty good there. If I had more time, I probably would have brought up the Brownsville NexRad. We could check that out. But that's just going to suck up bandwidth, so I'm not going to do that. But I'm going to switch over to the most unstable cape. This uses the layer with the highest theta E. And it looks like we can squeak out maybe 500 joules per kilogram in Louisiana, and maybe 1,000 just off the coast, and 1,000 is really what you need to have thunderstorms going on. So there's just not much support up this line here for thunderstorms. So let's go into the forecast. And I'm going to work out our thermodynamics on this chart right here. Okay, and you notice that the strongest thermal gradient is kind of concentrated right in this area here. And you might be tempted to put that line just ahead of that. But we've got kind of an unusual situation here where the front has kind of outrun that thickness gradient. So it's actually kind of like this. And you're not seeing much of a thickness gradient like right here in Texas. And the reason for that is the air mass is very shallow through this layer right here. We're sampling on this thickness chart the 1,000 through 500 millibar thickness. So this is 0 through 5. Just had some pills fall on the floor there. This is 0 through 5 kilometers. So this is surface through 18,000 feet. And this layer here is only maybe 1,000 or 2,000 feet thick. So it's not really being represented very well. If you really want to sample that, you could probably use something like the 850 through 700 millibar thickness. You can use all kinds of different measurements if the website you're using supports that. But in this case, all we have is 1,000 through 500 millibars. So we're going to place the front like this. And we're keeping it ahead of this very strong pressure gradient in Texas. And we can bring that back, and we can see that the pressure gradient here is obviously being driven by that polar high. So we can bring that back up like that. Okay, then we have the warm front off the top of the map there. Now, a lot of people tend to forget about South Texas and Mexico. It's like when things disappear into Mexico, the Weather Channel and a lot of places like that just forget about what happens. But I'll show you something pretty cool here. Let me scroll down a little bit, and I'll show you the temperature plot here. This is the 21Z plot. This is basically the high temperatures for today. So in Texas, we're looking at 50s around DFW. There's 67 at San Antonio. And what we see down in Mexico here, we've got 87 there at Monterey. And I forgot the name of that city. We got 77 here, 88 here, 86. We're going to see these values change. So basically, we've got 80 to 88, 77 to 88. Okay, let's watch what happens when we scroll this to tomorrow. Same time. Okay, quite a change there, huh? Now we've got 60s, 65. So in some respects, the temperature swings are even more extreme down there. Highs of 61, that's pretty close to what we have in East Texas. So I'm kind of curious if that cold air mass is actually going to reach through the mountains and hit the west coast. So let me check that real quick, because I really don't know. Okay, for tomorrow, we've got 102 right here, 98, 93. Man, it's like summer there. Let's see what happens. Sunday. Oh, okay, hang on. We don't have a 21Z chart for Sunday, so let's see if we... Let me go back to Saturday. Okay, Saturday at 0... Okay, yeah, Saturday evening, 88. This is a cool down from 21 to 0Z. 85 to 88 degrees. Okay. So the same chart on Sunday. Yeah, 85, 87, 88. The front is not reached there. It's probably being blocked by the mountain range right there. And then we go to Monday. 82. Yeah, now we're getting a little bit of a cool down there at 82. And then by Tuesday, got 179 there. Yeah, it looks like they get a little bit of cool air working through there. So anyway, let's see what is going on with our forecast up north. Obviously, we're taking aim on this front for the eastern U.S., and high pressure in the central U.S. is moving on in and driving this cold air mass southward, which is centered on the Dakotas and obviously heading for Missouri and Tennessee and Kentucky. So for tomorrow, when you join the webcast at the same time, we're going to be looking at this pretty strong storm system in Ontario and western Quebec. Okay, so front is going to be looking like this, maybe even a little bit further south, probably something like that. And I'm going pretty far south because you can see we've got that pressure gradient down here. So I'm keeping the front kind of a little bit ahead of that. So high pressure moving into Texas and Oklahoma, and that'll keep the winds pretty calm. It should be a very nice day to be outside if you don't mind some chilly weather. Probably going to get very cold quickly after the sun goes down. And the core of the polar air is heading into Ohio at this point. Then for Sunday, for our webcast on that day, looks like a very blustery day in New York and New England. There's the core of the polar air heading into New York. Let's see what the temperatures are going to be like on Sunday. Scroll this forward. Okay, these are going to be evening temperatures just slightly after the sun goes down. Yeah, below freezing across much of Pennsylvania. And I think that's 39 there in New York City. So, yeah, that's going to be pretty cold, especially with the wind blowing right there. Things are starting to warm back up in Texas. Not by much. GFS is going for 40s in East Texas and starting to get 50s in West Texas. So, yeah, this is probably a pretty dense air mass. The recovery is probably going to take a while, though. So even though this is a warm air advection pattern, we're not seeing much warm air in place. And next system coming in from California there, so got to keep an eye on that. Just as a reminder, this is Sunday. Now we go into Monday. For our Monday webcast, system coming through the Rockies. There's a low pressure area right there, front through New Mexico and warm front through Kansas. High pressure now moving into the eastern U.S., so things kind of moderate there a little bit. Still blustery in New England. And then for Tuesday, system coming into the southern plains right there. And I don't know what our moisture recovery is going to look like. Probably not very good. So this is probably just going to be kind of like showery type stuff. Okay, then we'll just go ahead through the rest of the week real quick. Wednesday into Thursday. Things look pretty, looks like pretty mild, very stagnant weather. Well, I wouldn't call it stagnant. We've got systems coming through, but should be a little bit on the fair side. Maybe just kind of partly to mostly cloudy and dry for the most part. Another system comes through the northern plains. This is going to be Saturday. Things stay okay down in Texas. And then for Monday and Tuesday next week, looks like we got a major system developing here on Wednesday the 30th. And this looks like it's going a little bit deeper with this system here. And the GFS thinks there's some potential here for severe weather. And that's certainly possible because during the cool season, November through December, January, February, that's severe weather season in this part of the country here. So we do have to keep an eye on these systems when they come Mississippi, and Alabama. It's getting my M states all mixed up. Okay. Then after that, it looks like it's building in a big Pacific front into the western U.S. and then another system here. So that pretty much wraps that up there. Okay, guys, I appreciate you watching, and I think that's about all I got. Let me check over on the chat here. Okay, things are looking good, and Sarah said reached the upper 60s in northern Indiana with severe thunderstorms this evening. Northern upper 60s there. All right. Anyway, I appreciate you all watching, and hopefully we'll see you all at the same time tomorrow. And I hope you all have a good evening.